Hi Geometry, welcome to 5.3. Use angle bisectors. Remember how we construct an angle bisector? You should also be practicing constructing the perpendicular bisectors for last section. We will have a mnemonic at the end talking about angle bisectors, so hopefully I don't forget. This is kind of what it looks like if I do forget. So it's Saturday night and I'm already tired, so thought I could crank out a video. Here we go. So I can use angle bisectors to solve problems like finding distances, distance relationships, and I can find the incenter of a triangle. It's going to be neat because after we find all of these special points of concurrency, you can put them all together in a project later on at the end of the chapter. All right, so here we go. First of all, let's start solving. Solve for x. Okay, now my notes are going to look slightly different on the video from your notes, particularly page 4 and 5, but bear with me. It's pretty much the same stuff. Okay, BD is an angle bisector, so that means I know that this angle is the same as this angle. So I'm going to set them equal to each other. 2x plus 50 is equal to 5x plus 5. And I want to solve for x, so I'm going to subtract 2x on both sides. So I'll have 3x equals, and then subtract 5 on both sides. 45. Divide both sides by 3, x is equal to 15 degrees. And we can substitute them in to find out what each value is, but this one just says solve for x. Okay, I left space right there, and I did the work right there. Isn't it special? Okay, the next one. Solve this equation. So x squared plus 12 squared is equal to 169. X squared plus 144 is equal to 169. I'm going to subtract 144 on both sides. X squared is equal to 25. And this is where, or why it says be careful, x is equal to plus and minus 5. Okay, so not just positive 5. And this is going to come up today. The legs of a right triangle measure 15 and 20. Find the length of the hypotenuse. So we're going to use Pythagorean theorem. 15 squared plus 20 squared is equal to h squared. 225 is 15 squared plus 400 is equal to h squared. Add them up, I get 625. Take the square root, h is equal to 25. Now it's not plus or minus because we're dealing with an actual distance. Okay, so I know, confusing, but bear with me here. Alrighty here. An angle bisector is a ray that, let's just underline it, just helps the notes look a little prettier, I think, that divides an angle into two congruent adjacent angles. See how it's marked right here? These are both going to be congruent. Remember also that the distance from a point to a line is the length of the perpendicular segment from that point. So basically the distance will be a perpendicular segment, and it's going to so happen that these are going to be congruent. So in the diagram, CP is the angle bisector of angle ACB, and the distance from P to CA is PA, where they are perpendicular. So these are perpendicular. And we are going to learn that these will be the same length. Okay, so this theorem is going to go onto the picture for the next, on the next page, okay? So I tried to work it out, it just didn't come out the way I wanted. All right, here we go. A point is on the bisector of an angle, then it is equidistant, that's the thing I was talking about right here, from the two sides of the angle. So if AB bisects angle CAD and those segments are perpendicular, then they are also going to be congruent. So see the diagram on the left. Okay, so what they're saying is basically this is happening. Okay, focus that, these two. So AB is a bisector of angle CAD. B lines up, let's see here, and is equidistant from the sides. So they're going to be perpendicular bisectors right there. So the converse, if a point is on the interior of an angle and is equidistant from the sides of the angle, then it is on the bisector of the angle. So if it's perpendicular and equidistant, that means it's on the bisector. So you'll know this will be happening too. Okay? I had to add that in. I corrected it on your notes. Okay, let's do some examples. Are you ready? Okay. This one's actually just really easy. So in the diagram, AE is a bisector of BAD. And find the measure of BAE. Well, if this one's 54, this will be 54. Okay, that's it. All right, example 2. So in the diagram, YL is the bisector, so that means this angle is congruent to that one. So what's the measure of YAL? So I'm going to set them equal to each other. 7x plus 17. Yeah, remember you don't like the red. Let's try to go over it with black. 7x plus 17 is equal to, I'm going to go ahead and distribute these, 12x minus 3. I'm going to subtract the 7x on both sides, and then add the 3 to both sides. Divide by 5. X is going to equal 4. Now, what is the measure of angle AYL? So I'm going to substitute that in. So I have 7 times 4 plus 17. When you work that out, you get 45 degrees. Now, if AL is equal to 10, what is BL? 10. Okay. Pretty straightforward, huh? Okay, here's our next little activity. Hopefully you're ready for this. Draw a triangle. Okay, so I got my straight edge. It doesn't matter what kind of triangle you have. And then it says, draw a circle inside so it touches all 3 sides of the triangle. Yeah, this is kind of hard. So I gotta somehow figure out how I can touch all 3 sides of the triangle. Yeah, this is gonna be hard. Oh, I did a pretty good job. Okay, so I want you to play around, and we do have a little bit of an issue here, a little bit when I'm outside, but the whole goal is to try to get it inside. But I think I did a pretty good job. I'm impressed. Okay, now we're going to construct 3 angle bisectors of a triangle. The point of concurrency is called the incenter. The incenter is equidistant to all 3 sides of the triangle. The incenter is always inside the triangle. So I'm going to actually make a pretty big triangle here, because remember we're doing angle bisectors. I'm going to make 3 of them. Do you remember how to do that? Okay, so here we go. To make an angle bisector, put an arc, 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 and then I'm going to, we'll do this in red for the first one. And then, I want to use different colors. Do I have another one that's a different color? Okay, so let's do this angle bisector. Arc, arc, and arc. And let's do that in, where's the other pen? I just found it. Let's do that in green. Hopefully this works. See, when you have a lot of pens sitting here, sometimes they don't work. Whoa, craziness. Woo. And let's do one last one. And it's kind of a turquoise color. And what do you notice? They meet at this point. And that point is called an incenter. So the incenter is going to be the center of the circle that I will use to make my inscribed circle. Let's see here. And if you look, there's a little tiny bit of human error, and that's happening kind of like a little bit right here and right there. So I'm off a little bit. It's hard to do, but I did touch right there. So much easier. In fact, I was hoping I would have butchered this one, but I did a pretty good job. But that's how you find your incenter. An incenter will make an inscribed circle, a circle inside your triangle. All right, let's do some more examples. Hopefully this is still recording. I don't have to do this again, but here we go. For what value of x does B lie in the bisector? So in order for this to be a bisector, this segment has to equal that one. So 2 times the quantity, x minus 1, and again I'm using the red. Sorry, I'll go back over it in black. Is equal to 3x minus 11. So I'm going to go ahead and distribute. 2x minus 2 is equal to 3x minus 11. I'm going to, it's not black, it's blue. In any case, I'm going to subtract 2x on both sides. And then add 11. We get x equals 9. So they just wanted a value of x. They didn't want us to substitute it in. But if we were going to, this would be 3 times 9 is 27 minus 11. That would tell you your segment length. Okay? Okay, now we have actually just a bunch of definitions and stuff. I don't know if we have any more examples. We'll see. But concurrency of angle bisectors of a triangle. So this is what I just told you that we did. The angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangle. So we know that this segment, let's see here. Actually, no, they don't have that. This is just the angle bisector. Sorry. This segment, and this segment will all be equal. Okay? And the name of that is called an incenter right here. So it's in green. This is an incircle or an inscribed circle of the triangle. I like how they use dots here to show the congruent angles. So here we have n. If NM, okay, these are the angle bisectors, sorry, NK, MK, and OK of this triangle, then TK equals UK equals VK. I kind of like that. So there you go. Now, example 4, it says, in this diagram, oh, you don't have all the information on here, so I'll have to write down some more information. I know that this segment right here is 12, and this length is 13. Okay, so what we have right here is a right triangle. But we want to find the length of PE. Keep in mind, these three segments are all going to be congruent. So let's take a look at this right triangle. If I find this segment, it's going to be the same length as PE. What kind of triangle do I have? A right triangle. And how do you solve a right triangle? Pythagorean theorem. So x squared plus 12 squared is equal to 13 squared. X squared plus 144 is equal to 169. When you subtract that on both sides, x squared is equal to 25, x equals 5. And this is why we had Pythagorean theorem in our warm-up. Alright, so we're just about done here. And just a little bit of vocab, some bigger pictures to help you. Again, I told you I like how they use the dots there. But look at this. Angle bisectors versus perpendicular bisectors. Okay, so I want you to see what we learned the last section and what we're learning now. They are different, and you should remember both of them. This one makes an incenter, a circle inside the triangle, and the perpendicular bisectors made a circumcenter, a circle outside. Okay, so here's our homework and our Common Core standards. And once again, in case I'm glad I didn't forget, this is a little mnemonic to help us remember incenters. I am beautiful. An incenter, angle, bisectors for I am beautiful. All right. Everybody have a nice evening, and I'm hoping you're enjoying your long weekend.